Thanks for tuning in to SpaceX Daily, episode 28. It's July 10th, 2026, and I'm Patrick in Vancouver. From Starbase to orbit, here's your SpaceX rundown. Booster 20's rollout to Pad 2 and the 420-ton crane installation at Cape Gigabay mark concrete steps toward higher Starship flight cadence and ground operations. Teams rolled Booster 20 out for testing on Pad 2 ahead of the integrated flight test campaign. The hardware move continues the established sequence of positioning boosters for static fire checks and pre-flight preparations. This step aligns with the ongoing Starship program arc that last saw Flight 12 hardware flow and now advances the open questions of rapid reuse and orbital refueling timelines. The action keeps Flight 13 preparations visible on the test manifest, while engineers monitor catch hardware integration status. Observers can next track static fire telemetry releases and any updates on tower compatibility. Installation of the 420-ton crane at the Cape Gigabay facility enables direct handling of Starship vehicles and Super Heavy boosters during stacking and repositioning. The equipment supports breaking over and moving stages between storage, integration, and pad transfer without relying solely on Starbase infrastructure. This addition expands operational flexibility for the Starship program by creating parallel ground processing capacity at a second coastal site. Integration testing with actual hardware will confirm load ratings and alignment with transporter systems. The crane directly addresses the reuse cadence constraint by shortening vehicle cycle times. A new Starship configuration completed its test campaign and met the targeted performance objectives. The results validate structural and thermal design updates incorporated ahead of the next flight test window. Data from the test feeds the iterative hardware loop that targets full booster and ship reuse, plus orbital refueling demonstrations. Engineers will now review telemetry to adjust parameters for subsequent builds. The outcome maintains momentum on the flight test campaign that began with earlier integrated missions. NASA assigned the Roman Space Telescope to a Falcon Heavy launch in August for exoplanet searches and dark energy studies. The heavy lift vehicle provides the payload mass and volume margin demonstrated on earlier national security and science missions. This assignment continues Falcon Heavy's role for observatory-class payloads that exceed Falcon 9 performance envelopes. Processing schedules at the Cape will determine final launch readiness. The mission adds another high-value science flight to the Falcon manifest. A Falcon 9 will deploy 24 Starlink satellites from Vandenberg Space Force Base, extending the constellation's coverage footprint. The mission sustains the record reuse cadence on the Falcon fleet while Starlink scales direct-to-cell and broadband capacity. Booster flight counts and turnaround intervals will be measured against the annual launch rate ceiling tracked in prior episodes. The Vandenberg site continues to support polar and high-inclination Starlink planes. Launch timing remains subject to range and weather constraints. SpaceX placed more Starlink satellites into orbit during the first half of 2026 than in any previous 6-month period. Sustained Falcon 9 flight cadence and the opening of additional launch sites drove the increase. The record directly expands on orbit capacity that supports subscriber growth and direct-to-cell service questions. Future quarters will reveal whether manufacturing and regulatory limits allow the pace to continue. The deployment total reinforces Starlink's contribution to overall constellation density. iSpace secured rideshare lunar delivery slots aboard Starship for cargo missions ahead of dedicated SpaceX lunar operations. The contract places iSpace payloads on early Starship lunar flights while the vehicle matures toward operational lunar capability. The arrangement tests shared transport economics before Starship lunar cadence scales. Payload integration schedules will set the timeline for the first flight opportunity. This deal builds on prior eSpace announcements about lunar freight services. The Japanese startup Elevation Space is signing customers for its re-entry capsule while tracking SpaceX commercial return developments. The vehicle targets independent re-entry services outside Dragon's crew and cargo manifest. Dragon's proven re-entry performance continues to define technical benchmarks for new entrants. First mission timelines depend on regulatory approvals and hardware qualification. The effort illustrates growing commercial interest in return capability. One thing worth watching is that environmental and scientific groups filed comments urging the FCC to pause review of orbital data center constellation applications, citing insufficient oversight of mega constellation impacts. The groups argue that moving compute hardware to orbit increases collision and spectrum risks before adequate rules exist. Resolution would require the FCC to complete a broader rulemaking on large LEO systems before granting new authorizations. Observers on our SpaceX noted Booster 20's rapid movement to the pad after earlier testing, with some users updating prior predictions about rollout timing. Photos of Thursday's Falcon 9 ascent from Florida showed the characteristic jellyfish plume pattern created by exhaust interacting with upper atmosphere ice crystals. Users tracked the environmental petition to the FCC regarding orbital data center applications, highlighting concerns over spectrum and debris from large constellations. On the AI front, Elon Musk stated that SpaceX could exceed Earth's total value if its goals are met, linking the comment to the first public reveal of an AI satellite concept. The architecture places processing nodes in orbit with data routed over laser intersatellite links already proven on Starlink. Environmental groups separately called for a halt to orbital data center applications, arguing that compute constellations require the same regulatory scrutiny already applied to broadband mega constellations. From an engineering standpoint, the 420-ton crane now installed at Cape Gigabay addresses a fundamental constraint in Starship ground operations: how to move and orient two massive, integrated stages without dedicated heavy lift hardware at every site. Raw structural steel and hydraulic capacity set a floor cost measured in tons of material and kilowatt-hours of fabrication. The finished crane multiplies that cost by the need for precision positioning, safety margins, and integration with existing transporter systems. By collapsing the number of handling steps required between storage, stacking, and pad transfer, the crane reduces both time and risk per vehicle cycle, directly attacking the reuse cadence bottleneck that still limits annual flight rate. The design choice also reflects a first principles trade-off between site specialization and fleet scalability. A single crane sized for the full booster in-plus ship stack avoids the need for multiple smaller lifts or custom fixtures, lowering the idiot index of ground operations relative to a more fragmented approach. This mirrors earlier decisions at Starbase where tower and transporter geometry were sized to the vehicle rather than forcing the vehicle to fit legacy equipment. Parallel site capability further distributes thermal and structural loads across two coastal facilities, reducing single-point weather or maintenance risks that previously constrained launch tempo. What the crane unlocks next is the ability to sustain parallel processing flows at two coastal sites, which in turn supports the higher launch tempo required for orbital refueling demonstrations and sustained Starlink replenishment. Load testing sequences will reveal actual cycle times versus theoretical projections, and any deviation will highlight remaining friction in transporter crane interfaces. Listeners should watch how quickly the crane completes load testing and enters routine operations, because each successful cycle trims the marginal cost of the next flight. The same logic that drove Raptor engine iteration, reducing the gap between raw material cost and delivered performance, now applies to ground systems, where every saved handling step compounds across dozens of annual flights. And a quick market note: SPCX is at $152.16, down 0.1%. Before we go, watch for load test results on the new Cape crane and any telemetry from Booster 20's upcoming static fire. That's the day at SpaceX. That's a wrap. SPCX is trading at $152.16, down 0.1%. If you're new here, subscribe and this briefing finds you every day. I'm Patrick in Vancouver. Thanks for being here, and I'll see you tomorrow. And before you go, this show is part of the NARA network. a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Tesla Shorts Time, your daily deep dive into everything Tesla. Find every show free at naranetwork.com. Want the written briefing with source links? Each show keeps a summaries page on naranetwork.com. Scannable, dated, and free. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.